The internet feels invisible. A message appears. A video loads. Money moves. A website opens from somewhere on the other side of the planet. It all feels almost instantaneous, almost weightless. But beneath the digital world is something physical, something enormous, something most people never see. Cables, thousands of kilometers of fiber optic infrastructure crossing the ocean floor, connecting continents, connecting cities, connecting financial centers, connecting data centers, connecting the systems that modern economies increasingly depend on. We think of the internet as a wireless world, but much of the global system still moves through physical infrastructure beneath the water. And that creates a fascinating contradiction. The world's most important digital network depends on some of its most physical assets. The internet looks decentralized from the surface, but underneath it, there are routes, there are landing points, there are bottlenecks, and there are systems that control how information moves between continents. When two continents communicate, the information needs a path. That path may cross thousands of kilometers of ocean. And unlike the digital images we see on our screens, the path itself is physical. Fiber optic cables carry pulses of light. They travel across the seabed. They pass through carefully engineered routes. They eventually reach land through cable landing stations. From there, the information enters terrestrial networks, data centers, internet exchanges, cloud infrastructure, telecommunication systems, and finally, the devices we use. The process feels simple from the user's perspective, but the architecture beneath it is enormous. A single click can depend on infrastructure that crosses an ocean. A financial transaction can depend on a physical cable buried beneath the seabed. A cloud application can depend on a route connecting two continents. The distance disappeared from the interface. The infrastructure did not. Now follow a single piece of information. It begins on a device. It enters a local network. It moves into a larger network. It reaches a data center. It travels through fiber. And if the destination is across an ocean, it may eventually enter a submarine cable. The information does not simply disappear into the internet. It moves through infrastructure. Every layer exists for a reason. Every connection has a physical path. Every path has capacity. And every physical system has limits. This is what makes the internet different from the way we imagine it. The internet is not one network. It is an enormous collection of interconnected systems. Networks connecting to networks, data centers connecting to networks, cities connecting to cities, continents connecting to continents. And beneath all of those relationships, physical infrastructure carries the information between them. But the cable does not remain underwater forever. Eventually, it reaches land, and this is where another layer of the architecture appears, the cable landing station, a physical point where an international route enters the terrestrial network. Suddenly, geography matters again. A cable may cross an ocean, but it must eventually reach a specific place. That creates concentration. Multiple routes can converge around important coastal regions. From there, traffic moves into national networks, data centers, exchanges, and metropolitan infrastructure. The ocean may be enormous, but the connection between the ocean and the economy is not infinite. It passes through physical points. And whenever large amounts of economic activity pass through a limited number of physical points, those points become strategically important. The bottleneck is no longer hidden in the ocean. It is sitting on the edge of the land. Connectivity is not simply a technical convenience. It has economic value. Faster communication can reduce friction. Reliable networks allow businesses to coordinate across borders. Financial institutions move information between markets. Cloud platforms synchronize systems across regions. Companies operate across continents without physically moving their employees or equipment. The network becomes part of the business itself, and this changes the economics of distance. A century ago, distance was measured in days, weeks, and transportation costs. Today, distance can be measured in milliseconds, but those milliseconds depend on infrastructure. The faster the network, the more valuable the connection can become. And the more valuable the connection becomes, the more important the physical infrastructure supporting it becomes. Connectivity stops being a background utility. It becomes part of the competitive architecture of the economy. And building these routes is not simple. The cable must be manufactured, tested, transported, loaded onto specialized vessels, installed across the seabed, protected where necessary, connected at landing stations, integrated into existing networks, and maintained over time. This is infrastructure with a long physical life cycle. It requires engineering, logistics, capital, permits, specialized equipment, specialized ships, and knowledge that cannot simply be created overnight. That matters because infrastructure creates barriers to entry. A digital application can be launched quickly. A global submarine cable cannot. The physical layer moves more slowly than the software layer. And whenever the demand for digital connectivity grows faster than the physical infrastructure can expand, capacity becomes valuable. The cable becomes more than a piece of glass and plastic. It becomes a piece of economic capacity. For centuries, oceans carried trade, ships moved goods, ports became centers of commerce, coastal cities became gateways between economies. The digital economy did not eliminate this geography, it built another layer on top of it. Today, information follows routes across the same global geography, but instead of cargo, the network carries data. Instead of ships carrying physical goods, fiber carries digital information, and the strategic importance of the route remains. Whoever connects major markets can become part of the infrastructure that enables commerce between them. The difference is speed. A ship may take days or weeks. Information moves in fractions of a second. But the underlying principle is remarkably similar. Economic activity depends on routes, and when routes become essential, controlling access to those routes creates leverage. But every physical network has a weakness. A cable can be damaged. A ship can interfere with infrastructure. Natural events can affect routes. Equipment can fail. And when a cable goes offline, the network has to respond. Traffic can move through alternative routes. Redundancy can protect the system. Multiple cables can provide resilience. But redundancy does not eliminate geography. It simply distributes the risk, because the network still depends on physical routes. And when several routes connect the same region, those routes become part of the strategic architecture of that region. This reveals something important. The internet is resilient, but resilience does not mean invulnerability. It means the system has been designed to survive individual failures. And the more important digital connectivity becomes, the more important that resilience becomes. So, who owns the internet beneath the ocean? The answer is more complicated than a single company. Telecommunications operators, cloud providers, technology companies, infrastructure investors, consortiums, national systems. Multiple participants can have interests in the same physical network, and that is what makes the architecture so interesting. Control does not always require ownership of everything. A company can gain strategic importance by controlling a critical route. A region can gain importance by hosting a major landing point. A cloud provider can strengthen its position by building connectivity between its data centers. A telecommunications company can become essential by operating infrastructure that other networks depend on. The system is distributed, but distributed does not mean equal. Some positions inside the network are more important than others. And this reveals a larger principle of modern economic power. Power does not always come from controlling the final product. Sometimes it comes from controlling the route that allows the product to exist. The network, the connection, the infrastructure, the path between two markets, the system beneath the visible economy. A submarine cable does not look like a financial asset. It does not look like a technology platform. It looks like a cable lying on the ocean floor. But that cable can connect economies. It can carry information between businesses. It can support financial systems. It can connect cloud infrastructure. And when enough economic activity depends on the connection, the physical route becomes strategically valuable. The power is not in the cable itself. The power is in what the cable makes possible. And now the system becomes visible. The cable is only one layer. Beneath the ocean is a network. Above the ocean is an economy. Data centers depend on connectivity. Cloud platforms depend on networks. Businesses depend on cloud systems. Financial markets depend on communication. Digital services depend on global access. Millions of economic activities depend on the ability to move information. The cable does not create all of that value, but it enables the movement of information that allows the value to flow. And that distinction matters, because infrastructure does not always capture value directly. Sometimes it captures value by becoming essential to the system that creates it. The network becomes the foundation. The economy builds on top. And as dependence grows, the strategic importance of the foundation grows with it. For most people, the internet is a screen, a browser, an application, a connection that simply works. But beneath that simplicity is a global physical architecture. Cables, landing stations, data centers, networks, exchanges, power systems, and thousands of physical connections operating continuously. This is the digital foundation of modern civilization. It is invisible because it works. And the systems that work quietly are often the systems people notice last. But when they fail, the architecture suddenly becomes visible. That is the paradox of infrastructure. Its greatest success is invisibility. The better it works, the less we think about it. And the less we think about it, the easier it becomes to underestimate its strategic importance. So, what is the internet really built on? Not simply software, not simply satellites, not simply data centers. It is built on connections, physical connections that allow information to move between systems, between markets, between continents. The submarine cable is one of the clearest examples of the hidden architecture beneath the digital economy. It is almost invisible, but it connects enormous amounts of economic activity. And once you understand that, the internet begins to look different. The cloud is no longer floating somewhere above the world. Digital commerce is no longer weightless. Global communication is no longer abstract. Beneath the screen, there is infrastructure. Beneath the infrastructure, there are routes. Beneath the routes, there are strategic positions. And whoever controls critical connections may influence how the digital economy moves. Because the visible internet is happening on our screens, the infrastructure that makes it possible is running beneath the ocean.
Nexera, decoding systems, architecting wealth.